This is an update on some technology I've been developing. I've given a few talks on how to further secure the internet and extend that security into the intranet. And I've done some development based upon what some others have been doing and some things I've added on my own. Anyway, as I mentioned, the internet is somewhat insecure. Of course, they put in some effort to guard the secret key, which is the keys to the kingdom, basically, in terms of internet security. But TLS generally ends at the border of the organization, so even guarding the secret key and using TLS doesn't ensure very good security. There's still a lot of people within organizations that will find themselves privy to data. So here's what I've been doing. The boundary of the internet is about there. They have TLS here, and that's pretty secure as long as you keep the secret key secret. So there is a technology called ACME, which allows spontaneous acquisition of a new secret key and a certificate. And they will, and certificate authorities that support ACME will allow you to get a certificate on the fly easily. You could even automate it with software. You don't have to no human intervention, but I don't think you can do it a lot. Basically, maybe you can, but so what I've got so far is, of course, I've made this unit here, which is a worker unit basically, and he'll still use a secret key, and it'll do a bunch of work. It's kind of a monolith, but the TLS will go all the way into here basically. And I do have an object here that's a proxy. It could be a load balancer. It would have to be a TLS load balancer that doesn't interfere in TLS, because TLS has to go all the way to the worker drone there. And that could fan out to multiple ones of these. So I have no problem with redundancy there. The issue is how this thing gets its secret key, and I've also written a Java base. I guess I'll put it back here. Java based ACME certificate acquirer basically, and these such data is kept in so-called database, and you can encrypt the database, but then what do you use for keys to access it? And of course the data going between the database is not necessarily secure. So I've created an ACME module that will deal with the ACME certificate authority, get a secret key, and then encrypt the secret key and keep it in the database. So even though that secret key may go back and forth to here, it's just garbage, baby. Garbage. Nobody will be able to tell what it is. They will not be able to steal it. They won't be able to compromise it and get it out here where they can spy on this data, and they won't be able to spy on this data. Ideally, each one of these worker units would have their own secret key. Maybe get a bunch of them in there, and getting it in and out of the database will be a secure operation. You'll have that secret key in here. It'll be negotiating TLS. And the only way you'll compromise any of the data between the database and the rest of the world is if you steal the memory that this program has going on. And that's handling TLS. There's a further issue that I had mentioned before. And it's not just the TLS or the certificates and the certificate authorities. It's all of the customer data. All the customer data is obviously kept in files and or mostly database. And of course you can encrypt the database and you can give out let people look at the database based upon background checks, etc., but there's thousands of people at every organization that's meaningful, and background checks are going to be spotty, and they're invariably going to have access to data they don't need to. It violates what's called least privilege. They may look in the database and see lots of customer activity, transactions, their personal information, phone number, address, and they don't need to. So my suggestion was to at least have a couple of databases, and one, you just reference it with control numbers, basically. So you look at that, you'll see a bunch of transactions, any kind of data, and it'll only be matched up to some number that's practically meaningless out of context. You would have to go to this other database to match that number up to a person, and this would have extra security. But still even then, that's still not secure enough. So another concept that people have espoused over time is password-based security. So customers themselves will establish a very good password. And this works for some things, perhaps not all, but the concept is good. Password-based encryption, we call it, and you will use the password to change the way the data looks. So as it gets into here, it's encrypted, and even though you may match it to some number that you can look up in the identity database, it's just garbage anyway. So it's useless. So this is garbage. Hardly anybody has access to this, and no matter who you give out access to the database to, they're not going to make very much of it. And what's more, added benefit is this worker unit that had spontaneous TLS is going to be back and forth to the database with password-based encrypted information. And this is now perfectly secure, sitting at rest over here in the database. It's perfectly secure. So the whole organization is pretty secure. And not only are you secure from voyeurism from people who work at it, but hackers who get onto that computer and get their instructions running on the computers there are only going to see this. And they'd have to do a pretty good job of getting data out of the memory of these worker units in order to make anything of what's going on. So, and I have instituted this so far, both ACME and password-based encryption, segmentation of identity from relative information, a load balancer. I got a good start on. They'll use the data will remain in TLS encryption and still be able to fan out to various workers. Guess that's all.